Thanks, Salma. I mean, that was absolutely fantastic. Perhaps Mo and I would disagree just on one point, and that point is there isn't a single asthma endotype. We would argue there is. It's called hay fever, where there is mechanism which is Ig mediated, there is biomarker, specific Ig, and there is mechanism-based treatment, which is allergen immunotherapy. You don't see these people unless there's thunderstorm and they die of asthma attack or are admitted to hospital, but they end up in our clinic. But I fully agree. I mean, that was absolutely, absolutely fantastic talk. And I mean, it does sort of beg the question. We've talked about biologics and how and where, and what I'm going to argue is that perhaps we should contemplate, think about expanding the use of biologics into earlier age. And, you know, the question is, why would you bother? Why into earlier age? Well, you have heard these. You know, these are FDA-approved biologic agents for severe pediatric asthma. I know that currently in the region we only have omalizumab, but there's omalizumab, mepo, benralizumab, dupi, and tezepelumab. And the indications are clear. They're indicated in patients with moderate to severe persistent asthma, which is great. That is reflecting the cost. The question is, who are actually the patients who would benefit most, which may be slightly different if the cost of treatment was different. I mean, this is quite interesting. So again, in the US, omalizumab in context of asthma is registered in kids over the age of 6 years, and there is really, really, really solid evidence for this. Mepo is also registered for children over 6 years of age, and they got registration based on, as Andy has shown you, 26 kids who participated, well, children over age 12 and adolescents who participated in mainly adult trials. And I mean, I would say that that is pretty scandalous, particularly when you look at huge differential responses to mepolizumab observed in studies in adults and in recent studies in pediatric population where it was clearly underwhelming. Again, benralizumab over age 12 years, dupilumab in the context of asthma over age 6 years, but it is going down, particularly in the context of eczema, and also tezepelumab for any phenotype of asthma in children greater than age 12 years. But similar to the situation in adult medicine, unmet needs, and this is unmet need from our point of view, is we have absolutely no idea what is long-term efficacy and safety of these treatments, particularly in children beyond 12 years of age. A 6-year-old child is very different to a 12-year-old child, and trying to extrapolate from studies that have been done in ages 12 to 72 to children who are 6 to 12, I think is plain dangerous. What we desperately need, and you've heard it from all of the speakers, is much more precise classification of asthma and identification of specific biomarkers, and they're almost certain to be pediatric specific. And adult cutoff points, for example, for eosinophils of 0.3, which are suggested for use in pediatric population, clearly is inappropriate. There are huge inequities in access to biological treatment, and I don't need to tell you, you will really struggle even to try to contemplate using biologics. And as is the case in adult asthma, there are no data on comparative effectiveness and the optimal choice of treatment. But in pediatric medicine, we have moved actually into what Salman suggested we should be doing, which is academic-driven trials, which industry is never going to do. And this is the study that is currently ongoing in the UK, led by Sejal Saglani, which is asking very simple questions. You know, in this population of kids with very severe disease whom we consider for treatment with biologics, which one is better amongst eosinophilic patients? Is it omalizumab or mepolizumab? What I'm really, really pleased is also that, you know, we can do in academic medicine that the analysis is going to be much more intuitive. So one of the outcomes is going to be Bayesian analysis using clinician-elicited priors. And I think that will give us something kind of really, really more intuitive that We will, hopefully, in the next couple of years, be able to tell you the answer to the question, well, which of the two treatments actually works better, and whether we can have hints about what are the clinical characteristics of biomarkers of those individuals with differential responses. But, those are our needs, and obviously we have patient representatives here, etc., and the needs of patients may be fundamentally different from our needs as medical practitioners. So this is a study that we have done in the context of ERS, Preschool Wheezing Task Force, actually going to parents of children with troublesome wheezing and asking them, well, actually, what is that you need? What are your major priorities? And it's quite interesting. Actually, people do appreciate the difficulties in making precise diagnosis. They're not telling us, you're stupid, you don't know. They appreciate this is different. But the uncertainties surrounding the diagnosis, they feel they're left in limbo. And this is the term that has been used. They're left in limbo. The key areas which they identify where they need more information is, hooray, hooray, long-term prognosis. What is going to happen to my child? Which is really precisely related to what Salman was talking about. We need to intervene very early if we are to make any difference. The problem of using ChatGPT and you name it is, the information that they get can really be alarming because they cannot really comprehend precisely what that information means. Research gap, long-term prognosis, clarity on management, these are the important knowledge gaps. And quite frankly, I think it is our duty to address these gaps because this is the population for whom we are actually doing this. And then you ask the question, well, if we are to really be serious about prevention, long-term modification, then we need to understand what are the factors associated with the transition of the clinical feature we refer to as troublesome preschool wheezing to the disease we agreed to subsequently call asthma. So who are the children? What are the characteristics of children that go on from troublesome preschool wheezing? And Salman mentioned exacerbations. So this is an interesting piece of information. Yes, exacerbations are important. So several years ago, we looked at modeling. This is, again, application of machine learning models to understand the patterns of exacerbation during first 8 years of life. This is not asking people. This is actually collected from healthcare data. These are severe exacerbations that people used oral corticosteroids for, and it's quite interesting. Out of 10 wheezers, or out of 100 wheezers, let's say, 60 actually never exacerbate. 40 exacerbate. Out of 40 who do have exacerbations, there are two fundamentally different longitudinal patterns. Small proportion of them, 10% of them, have early onset frequent exacerbations. And they continue through life. And, about majority of them have infrequent exacerbations. Why is this important? And this is important precisely for the reason that Salman really, really importantly highlighted. Because the impact of exacerbation on lung function is quite extraordinary. So look at never wheezers, wheezers without exacerbation and infrequent exacerbations. So we modeled up to age 8 and then followed them for subsequent 8 years. Infrequent exacerbators, wheezers without exacerbation, actually their lung function is reasonably preserved. Amongst children with early onset frequent exacerbation, that's fundamental. I would say horrendous loss in lung function. I mean, what we have here is a loss of more than 10% in FEV1 FVC ratio. This is not 1%. I totally agree with Salman. I think every mil matters. Every mil matters when you get to that critical age of 23. I mean, this is not mil, this is hundreds of mils of loss in lung function. When they get with this lung function to age 25, I think, the game is up. The game is up because that level of lung function at physiological peak is the strongest predictor of ill health. Forget about asthma and COPD. It's a predictor of cardiac death, metabolic comorbidity, poor health. So we have to do something about this. And then the question is, well, why the heck? What is the mechanisms of this loss in lung function during childhood? Again, this is modeling. Danielle did. Now, as I told you, VP for AI and GSK, she did modeling. We were in a really good position to measure lung function in our birth cohort using body box measuring S-raw. So unlike FEV1, the higher the level here, the poorer the lung function. This is airways resistance. And what you can see here very clearly is that children who are at risk of progressive loss in lung function from very early childhood to middle school age are characterized by frequent exacerbation and multiple early allergic sensitization. And you in particular, trouble if you're a boy, quite interestingly. So what is this relationship between allergic sensitization, as we call it, and exacerbation? Exacerbation obviously is virus-driven. And Mike Edwards, who is working with us at Imperial and doing really fantastic studies in relation to immune mechanisms related to virus infections, propose, I think this is really great concept of reciprocal negative regulation between interferon, innate antivirus responses, and Th2 pathways. In that, if you have T2 signal, that actually reduces your innate antivirus responses, and vice versa, and then you're caught up in this vicious circle. This is also related to the nature of response to biologics. We ever talk, anti-IgE is anti-allergy drug, you reduce IgE binding on mast cells. Well, that is not how omalizumab reduces acute severe exacerbation. The mechanism by which omalizumab reduces the risk of exacerbation is actually through restoration of virus-induced interferon alpha responses. Beautiful study in the US. Before randomization, they looked at IgE receptor cross-linking in PBMCs, and it is clear, and as Mike speculated, it significantly suppressed rhinovirus-induced interferon alpha production. When you treat with omalizumab, interferon alpha responses in direct response to virus are increased. And the magnitude of that increased response is directly related to clinical benefit. So higher the increase in interferon alpha responses, greater the clinical response. So we should really start to be very careful in terms of making linear assumptions about what the mechanisms may or may not be. And then it begs the question, if we hit children early with omalizumab, hopefully improve their antivirus responses, will that have any long-term outcomes? The key question, will this have any disease-modifying effect? And this is a study that should have had its readout last year. Unfortunately, it was hit by COVID and then extended for another 2 years. I talked to Wanda Fipadanakul. She's doing a really lovely study of properly placebo-controlled trial of anti-IgE in kids aged 2 to 3 years who are deemed to be at high risk of asthma. And they have very, very carefully kind of identified these by the virtue of having at least 3 episodes of wheezing within first 3 years of life and have mothers with asthma. And then they are treated with omalizumab for 2 years or placebo and then followed for additional 2 years. So we will actually shortly they promise the readouts, I think, in the first quarter of next year, have at least some idea of whether there is any effect of this treatment on a long-term outcome in early childhood asthma. And imagine if we find that any of these treatments actually helps. Then comes the question, well, how the heck do we identify children who are going to potentially benefit? Is it going to be genetics? Can we pick it up based on immune response to viruses? Can we use multi-omics signature that Salman was talking about? We have been talking about sensitization, allergy a lot. And everybody says, well, you know, the problem with sensitization is 1/3, and this is our data, 1/3 of children who are sensitized are perfectly healthy. They have no symptoms whatsoever. 2/3 are symptomatic. So clearly, there is completely irrelevant benign sensitization, or there may be actually potent protective mechanisms at play there that suppress clinical expression of this, and there is pathologic allergic sensitization. But using our standard tests, we can't get it. Can we use CRD sensitization? So genetics, 17q21. What is the mechanism by which variants in 17q21 lead to expression of symptoms? This is recent work by Etuna Regis, one of our PhD students working with Seb Johnson and myself, where we looked at the relationship between genetic variants which are associated with asthma and innate immune responses to viruses, ascertained through direct stimulation of PBMCs by live human rhinovirus. And what is very, very, very interesting is that carriers of asthma risk allele in 17q21 have markedly lower rhinovirus-induced interferon beta responses. So at least part of this association is probably mediated by the nature of the innate response to viruses. Now, you can then integrate genetics and innate immune responses to viruses, and you can use complex analysis like Bayesian profile regression analysis, this one developed by Sara Fontanella, actually bringing all of the information on genetics related to 17q21 and their innate immune response to viruses. And children cluster into 3 clusters which are characterized by differing innate immune responses to viruses. Some who have, let's say, poor immune response to virus, those who are average, and children who have very robust signaling and high interferon beta induction. Now, what is really interesting, that the cluster that is associated with very low virus-induced interferon beta responses is also characterized by being homozygotes on all of the different the 17q21 variants and all of the risk variants which are associated with asthma. Is it then reflected in differing prevalences of the disease? Well, yes, it is, because children in cluster 1 with low responses and characterized by all of these different risk alleles have a hell lot of asthma. There's really interesting question there. In childhood, boys wheeze more than girls, right? And then it reverses during puberty. Why do boys wheeze more than girls? Everybody says, oh, it's this, that, or the other. I mean, clearly, sex hormones are not playing important role here, whether it's structure of lungs, etc. This is a paper that we have never actually had that amount of problem in trying to publish it. Paper that showed very clearly that, well, men, we are inferior species, I'm afraid, and girls have considerably and markedly greater induction of type 1 and type 3 interferons in response to rhinovirus and all of the different viral mimics. You know, when people talk about man flu, it actually is real. You know, we're rubbish. We're really rubbish. And this is probably the reason why, I mean, part of a reason why boys wheeze more than girls. And nobody liked it, really, because then you say, oh, well, I mean, it was done in the middle of COVID, and we said, well, obviously then, based on this, we'd predict that twice as many men are going to die from COVID than women, and that's exactly what happened there. But nobody liked the answer. But I think we need to think about it, and also it helps us. Well, should we sort of really look at these? And you remember Danielle's paper, boys, multiple early sensitization, exacerbation, loss of lung function. It kind of inference is the same. It makes sense. Multiomics, I mean, this is really, really, really interesting study published very recently, looking at altered epithelium, bacterial gene counts, really complex multiomic analysis, demonstrating very clearly that you can integrate various infection data, biomarker data, etc., to ascertain the risk. But my God, I'm telling you about multiomics, and here in Bosnia you can't do skin tests. It is the reality of inequality in access. What about sensitization? So, we all know, there is no question about that. Sensitization is associated with asthma. Fine. But there isn't a single asthma guideline that recommends this assessment in the diagnosis. And I actually agree with that, because there's such a huge overlap there that it is very, very difficult to use this information and make prediction in individual patient. But we are now having a hell lot better ways of measuring sensitization. There's something called component resolved diagnostics. So we can measure IgE to multiple different individual allergenic proteins. Some of the CRD microarrays measure more than 100 different IgEs to individual proteins. Some measure more than 250. Now, I have been playing with this in a research for best part of 20 years, and I have used it clinically twice. Claudia, how many times have you asked for Isaac? Never. Why? Because what I get from the lab is 8 pages. 8 pages and list of 112 individual allergenic proteins and whether it's positive or negative. And you think, what the heck? Why would I bother? What does it mean? But I would put to you that really utilizing the complex microarray data and then applying machine learning and artificial intelligence to create interpretation algorithms can actually identify those at risk, both in terms of diagnosis, assessment of severity, and most importantly, prediction of future risk. And in a series of studies, we have shown very clearly that complex patterns of interactions, not individual allergenic molecules, complex pattern of interactions actually predict asthma diagnosis, now with area under the curve of 0.95. In individual sensitized child and adult with asthma, we can predict whether that individual has severe or mild or moderate asthma with greater than 95% certainty, the information done in UBioPred. Now then you can look at what happens, what is the evolution of this complex response. And here is the data in our birth cohort going from school age 5, 8, 11 into adolescence. And what you can see clearly is that as children age, there is evolution of connection between these different CSIGEs. But sensitized, as a lot of people call them allergic, children with asthma have completely different patterns of connectivity compared to those without asthma. And this has just been published. And then you ask the question, okay, look at sensitized individuals only. So as Paul was arguing a couple of days ago, let's forget about all of these healthy non-sensitized. It's just it increases your area under the curve, and it's almost fraudulent. So looking at sensitized individuals throughout life course, sensitization networks completely separate those who have asthma from those who don't. And patients with asthma always form separate group from those without. Clear separation of their IG profiles. Now, this is completely unsupervised. I actually have no idea. I have a hint, I have opinion. How can this arise? But this is the case. We have another paper just accepted now looking at global differences, geographical differences across the globe, South America, Africa, Europe, US. And it is quite staggering that the patterns of sensitization differ between different geographical areas, obviously. But these complex interactions differ between those with asthma and without asthma. And amongst patients with asthma, there's clear separation between those with severe and mild asthma. So what I hope is that as these patterns are consistent, as the age increases, the separation increases, and I think we are moving towards actually coming with interpretation algorithms that may make this test useful, may even persuade me to use it clinically. And, you know, when you come to me and say, oh, does my child have asthma? I can get you the probability based on test alone. Will my child have symptoms in 10 years? We can get that information with reasonable amount of clarity. There's another reason why I think we need to think about expansion of biologic use into a younger age beyond asthma. And the reason for that is, you know, in Claudia's clinic, she sees patients with multisystem allergic disease. And this really, really, really is a huge clinical problem. And some people refer to this as allergic march. All of our data clearly shown that the idea of progression doesn't exist. But we call it allergic multimorbidity. And these are children with multiple different clinical presentation, from their really, really difficult eczema, difficult airway symptoms, eye symptoms, nose symptoms. But interestingly, when we do the modeling of symptoms across the life course from birth to adolescence, what is really clear in this very elegant Markov model of disease transition during life course is that this critical, troublesome, clinically important feature of multimorbidity starts very early, age 3. By age 5, the time is up. It's established. We now have follow-up up to here, age 30, and it remains very stable. And then it begs the question, okay, so if we go and start interventions at the age of 30, 35, are we far too late? Should we be starting, getting with interventions early, age 2 to 3, 5 years? And will that have any impact on the development of lung function and ultimate health? That's why I think we really need to think very carefully, very, very carefully about how we address this very early, because we know that our treatment like steroids are utterly useless. Okay, they do not modify the disease. We hit kids with inhaled steroids very early. The only thing we do is we induce impairments in lung function, because if you give inappropriately steroids in kids less than 1, of course, that modifies the development of their lungs. So, a lot of people have contributed to this. Again, people from Stella, people from Breathing Together, our new birth cohort, which has got all of the mechanistic data. It will never be as good as studies, and I totally agree with you, unless you have lung and organ samples, and unless you look there very carefully, it will be very difficult to actually fully understand mechanism. But that is where this integration of data comes together. Bioengineering, data science, mechanistic studies, and our CATSAT consortium. And with that, I think we probably are sort of at the dawn of new age. I'm still not quite sure how that new age is going to look. And I can see your point. Maybe triple biologic in adults is going to be great, but I don't think that will be applicable in young children, because in young children we have to think about developmental pathways. Hitting somebody with mepolizumab without us fully understanding what actually is physiological role of eosinophils, particularly those regulatory eosinophils, may be rather dangerous. With that, all of you who stayed, thank you so much. You have been absolutely wonderful. Salman and I decided we were going to be at the graveyard session, but it was a great pleasure talking to you. Vildana, Tonya, thank you so much for organizing this meeting. We have the speakers here. If you have any questions, now is the time to ask. Thanks very much.